Okay, this particular one now, we want to look at Laplace transform. Yeah, Laplace transform. Now, most of the times we'll be giving question in terms of t. We call it time domain, and then we'll be required to take it to S domain. That's one thing about this Laplace transform. So, looking at it now, we see that from the very definition of Laplace transform, look at it here, this one. The Laplace transform of a function t, function f of t is capital F of x, and that's the basis of Laplace transform. Knowing the Laplace transform of the very small f of t, that it is f of s, and then looking at this function now, this particular equation, the integral from 0 to infinity of exponential minus st f of t dt. This is the definition of Laplace transform. So any function you are given, whatever it is, you put it here and solve it. You will automatically get the Laplace transform. That's how Laplace transform is being done. Although there is a table for Laplace transform, but I want to show you this one first. You get. So this one you may be required to solve with the function to prove something. That's why you need to know this. Now, and most of the times you may be required to prove for that of f prime of t, f prime prime of t in most cases. So you just need to know both of them, how they are being done. But then I will teach you f prime of this of t. If you know f prime of t, you can be able to do f prime prime of t. In case you don't understand, you can still ask me later on, maybe in the comment also. Now, how do we prove that f prime of t is equals to f of s minus f of 0? I've already told you that f of t is f of s. How do we now prove that this f prime of this is equals to this? Let's go down and see how. Now, assuming f and f prime are nice enough so the integrals converge, from the definition we know that if we have Laplace transform of f prime of t, this will mean this. How? I told you earlier that if you have a function, an equation like this, what you just need to do, any function you have, replace f of t by the function you are given. In this case, we are working on f prime of t. I will replace it. Instead of having f of t there, I will have f prime of what? T. That's the definition of Laplace transform. Now, we want to integrate this to get the answer. We follow integration by parts. Yeah, integration by what? By parts. Whereby you have integral of v du. Integral of v, because look at this now. Is it v du? I'm coming. If we say this is u and this is our integral of u dv. The function, the formula says integral of u dv equals to uv minus integral of v du. That is the formula for integration by parts. So when you have that now, you'll be fighting for you to get your uv, and then you need to get your uv and the v and the u. But already the assumption whenever you're solving is that you know your u. Your u is exponential minus st. Then your dv is f prime of t dt. When you have these two now, you can get the u from u. You can get v from dv. Now, how do we now get the u from u? By differentiating u with respect to what? To this t here, the u dt. So the u dt will give you minus s exponential st. How? Because differentiation of exponential at is same thing as a exponential at. A exponential at. Now our a here is minus s. To go to the back, minus s exponential what? Minus st. That's what you have here now. So the dt just came in as part of the derivative, because this thing would have been the u dt. So when you multiply it out, the t will go to this other side. Now we have the v. We need to get v from the v. For you to get v back, we have to integrate, because this thing is differentiation of v. We have to integrate that dv to get what? V. When you integrate what was already differentiated, it will go back to the main function, which is f of what? T. Remember that f prime of t means f differentiated. So you have f of t. So going to put all these things in that formula I mentioned earlier. That's integration by part formula, which says integral of u dv, and u is this, and then dv is this, equals to uv. And you know that your u is this, and then your v, see your v here. So minus integral of v du. Your v, this is your v. And then, okay, this is your v now. Then your du is this. You see, ba? So when you have gotten this thing now in this formula now, the next thing is to solve this and get your final answer. You solve this side now. Whatever it gives you is your answer to what you were given. Remember, this thing now is same thing to what we were given from the beginning. See it here. So when we solve this, this one now, look at what happened here. This thing, this 0 to infinity were attached to all of them, because from the very first equation we started using, 0 to infinity is there. So we're going to replace t with infinity in this equation. The first time we'll put it infinity, then minus, we will now put 0 in the second one. When you put infinity here now, exponential infinity is almost 0, it's just 0. Minus, you put 0 here now. If you put 0 here, you have exponential minus 0 is 1. 1 times f of 0 is f of 0. So you now see that since you have exponential infinity, which is 0, minus f of 0, you have what? Minus f of what? 0. Yeah, that's what you have here now. Let me go up. So if you do this, this will give you minus f of 0. Minus f of 0 when you solve it. Minus, if you put infinity, if you integrate this first of all, if you integrate this first of all, but before you do that, you have to separate s. S have to come out. So when minus s comes out, you have plus s. You get back, because to combine with the minus here. So when you now work on 0 to infinity now, and then exponential minus st f of t, you don't need to solve this. Look at this now. This thing you are seeing is the meaning of Laplace transform. That's the question I told you about from the beginning. Integral of exponential minus st f of t is same thing as capital F of s. Yeah, capital F of what? S. It was the Laplace transform of f of t that gave us capital F of s. You get, so the whole of this thing now is capital F of s. Yeah, so you now have s f of s. Remember, minus f of 0 is still coming from here now. So that means the Laplace transform of f prime of t is s f of s minus f of 0. In case you have any question, you can ask. And I think that's how it is being solved. And so if you have something like f prime of t, it will become this this particular one. So it can also be proven in the same way. Yeah, in that case, when you be proving this particular one now, you will be using this to prove this. A point will reach when you'll be having this in terms of f prime of t, just like you had when you were solving this one. You arrive at the point where you have f of t. You see, but when you be doing this one now, you arrive at a point like this where it is now what? F prime of t. So you now replace f prime of t by what what your distance is. F prime of t is when you do the Laplace transform, which is this thing now. So if you have any question, you can ask me on the comment section. Thank you.